When you're working in data analytics, one of the most common operations that you'll perform is to read in a lot of data from a file. This can be a CSV file, a tab separated file, a simple text file, anything. Reading in data from files is very common, which means file operations in Python are something that you should be very familiar with. Open is a built-in function in Python, and it takes in a path to the file that you want opened. Here, does not exist or text is a file which does not exist, which means open will throw an error, and that's exactly what you see here. Python error messages may not always be clear to the beginner, but you'll get used to them bit by bit. Here it's pretty clear, no such file or directory does not exist or text. We tried to open a file which did not exist. The built-in function open takes in a relative or an absolute path to the file that you want opened. Here the path is relative. It looks for this file in the current working directory. It does not find it, which is why it threw an error. Let's use the open function once again. This time we'll provide an absolute path to the file that we want opened. /temp / does not exist dot text. This file doesn't exist as well, which is why this throws an error. Under my current working directory, I have a directory named data within which I have a file named students.txt. Jupyter notebooks allow you to execute shell commands from within your browser. So you can execute shell commands from within Jupyter as long as you prefix those commands with the exclamation mark. On Unix, Linux, and Mac machines, cat is a shell command that allows you to view the contents of a file. And I'm going to execute this cat command from within Jupyter. Notice the exclamation mark that I prefix this command with. The students.txt file contains information on 4 students, Kishore, Ajit, Virat, and Sachin, and their corresponding scores in 3 subjects. Let's open this file by calling the built-in open command. We specify the relative path to this file. It's under the data directory under the current working directory, and the file name is students.txt. Just a heads up for when we are working with paths. If you're on a Windows machine, use / to separate the path elements. If you're on a Linux or a Mac machine, use the /. So here you would specify data / students.txt if you're on a Windows machine. The path separator for Windows is the /, which is different from the path separator that we use in Unix, Linux, and Mac machines. The open function opens up the file. By default, the file is opened in the read mode to read the contents and returns something called a file handle. A file handle can be thought of as the gateway into the file. The file handle is what you'll use to read and write from a file. Let's examine the contents of the file handle. What is printed with F is, notice that it says that it's a text IO wrapper. It's reading a text file. The name is data / students.txt. Mode is equal to R. This is the default mode. This indicates that the file has been opened for reading. And the encoding shows how the file is encoded. This file happens to be in UTF-8. That's just an encoding format. You can ignore it for now. The file handle exposes a number of functions that you can use to operate on the file. For example, f.read allows you to read all contents of the file. Here are all the contents, the 4 students, their corresponding scores. Notice the \n special character after the record for every student. The \n stands for the new line. This new line character indicates the start of a new line on which the next record is present. Think of the file handle as a pointer which points to some position within the file. When you first open up the file and initialize the file handle, that handle points to the very beginning or to the start of the file. And as you read characters or bytes from the file handle moves over those characters as you read them. Let's say you want to read a certain number of bytes from this file. You'll call f.read and you pass in 7, indicating you want to read 7 bytes from the current position of the file handle. But the file handle previously has been used to read the entire file contents. We just did that in our previous command, which means the file handle is currently at the end of the file. When you try to read 7 more bytes, you get nothing. You've already reached the end of file. You can reset the position of a file handle back to the beginning of a file by calling f.seek and passing the position where you want the file handle to move to. If you specify 0, it'll go to the beginning of the file. If you specify 5, it'll go to the beginning of the fifth byte of the file. You'll mostly want to use f.seek to go back to the beginning of the file, as we've done here. And now if you try to read 7 bytes from the beginning of the file, you'll get the name Kishore. Every character is stored in a single byte. When you read 7 bytes, you get all characters of the name Kishore. Now, just by looking at the file handle, you can't really tell what its current position is. You don't know whether it's at the beginning of the file, middle, or the end. The tell method on the file handle will tell you what its current position is. Here it's 7 because we've read 7 bytes. Our file handle is now at position 7. Let's say we call f.read4. We want to read 4 more bytes. We'll start off with the current position of the file handle. That means we'll start off at byte 7 and read 4 more bytes. After Kishore comes the comma, the space, and the number 33. If you call f.read now without passing in some number for its input argument, we'll simply read from the current position till the end of the file. Let's go back to the beginning of this file and try some other stuff. We'll call f.seek and pass in 0. This takes us back to the beginning. Now, what if we wanted to read this file one line at a time? We just don't want to read all of the bytes in the file. We want to process this file one line at a time. And once again, we encounter the for loop. You can iterate over every line in a text file by simply calling for line in f, where f is the file handle. Here we iterate over every line in this file and print it out. Notice that when we print out the line, each of these lines are separated by an extra empty line. This is because of the print statement. The print statement automatically adds a new line after every line that it prints out. In addition, the line itself had the /n character at the very end, which is a new line. 2 new lines, which is why these empty spaces between the lines exist. After one line of text is printed, the first new line takes us to the next line. The second new line leaves that line empty, and we move on to the line after that, which is where the next line is printed. We'll use f.seek once again and go back to the beginning of the file. This time we want to read line by line from this file using the readLine method. The readLine reads one line at a time. The first line of our file contains the record for Kishore. Notice the \n at the very end. If you call f.readLine once again, it'll read the next line from the current file handle position, which is the next record for Ajit. Let's continue exploring other operations that we can do on the file handle. We go back to the beginning of the file, and this time we'll call f.readlines. Readlines returns all of the contents of the file in the form of a list of lines. Every line is a separate element in this list. Every line is a string which holds the information for one student, and every line except the last one has the \n at the end. Once you've finished working with the file handle and you've performed all the operations that you need to, it's good practice to close it. Otherwise, it's possible that an open file handle might corrupt the file. Once you've closed the file handle, you can't perform any more operations using that handle. Let's say you try to seek to the beginning of the file. This will be an error. We try to perform an IO operation on a closed file. When you program in the real world, it's quite painful to have to remember to close the file handle each time you're done using it, which is why Python makes this easy for you using the with statement. Let's see what that is. We'll first initialize the lines variable to an empty list. These will contain the lines that we read from a file, and then we use the with statement like you see on screen. Let's parse what's going on here. We have the with keyword followed by a file open command. We want to open the students.txt file under the data folder. We want to open this file in the read mode specified by the R character that you see as the second argument to open. Python allows you to open files in a number of different modes. You can create a new file, you can read an existing file, you can write to a file, or you can append a file. The R character passed to the open function indicates that we want to open this file in the read mode. We want to save this file handle in the f variable with open, the name of the file, as f. This is equivalent to the command that you see on screen. F is equal to open, the name of the file, in read mode. The advantage of using the with statement is that it sets up a nested block within which the file handle remains open. So notice the colon at the end. This is the start of the nested block. Nested blocks are what you've seen and used earlier in if statements, for loops, while loops, etc. Within this nested block with the right indentation, we'll write all the commands that use this file handle. Here we've set up a for loop to iterate through every line in this file using the file handle f, and then we've appended that line to the lines list. We haven't appended the line directly though, we've modified the line in some way. We call line.rstrip \n. This strips off the \n from the right side of the line, from the right side of the string. The resultant string after line.rstrip does not contain the trailing \n. The cool thing about using this with block is that as soon as we exit the with block, then the file handle is automatically closed. f.close is automatically called by Python. You don't have to worry about actually closing the file handle. If you now examine the contents of the lines variable, you'll see that it contains all the lines from our text file, but notice the \n at the very end has been stripped out, has been removed. Let's take a look at some more file operations using the different modes of a file. We start off by checking that more students.txt does not exist. If it does, we are going to remove it using the rm-rf command on our shell. If you're on a Windows machine, make sure you replace it by the appropriate command to remove this file or delete this file from your directory. Using the with command, we open the more students.txt file in the append mode. This will create a brand new file and the file handle will be stored in the f variable. Opening the file in the append mode as specified by A allows you to write to the file. Here we are going to use the f.write command to write one more record to the file for the student Anu. The return value from the f.write method is the number of characters that was written out, and we can print out the number of characters written to screen. We'll execute this. The record for the student Anu has 19 characters which were written out. Run the shell command to see the contents of this file. We'll use the cat command here because we are on a Mac OS. You can use the more command on the DOS shell. This file contains exactly one record for the student Anu. If you want to append additional lines to a file that already exists, it's the exact same open command. We open the same file more students.txt in the append mode as specified by the A character. We store the file handle in the f variable. f.write will write an additional record for the student Neeti. It'll append it to the end of the file and we'll print out the number of characters written, which in this case is 20. Let's see the contents of the more students.txt file now. We have two records within it, Anu and Neeti, but notice that the records are in the same line. This is because we didn't write out a \n at the end of every record. So there was no new line after the Anu record was added. So when we added the Neeti record, it continued in the same line as the Anu record. Using the \n correctly when writing out files is very important. Otherwise, you'll have multiple records which run together on the same line. The lines variable contains the lines that we read in from the students.txt, the original file that we read earlier. This contains 4 student records for Kishore, Ajit, Virat, and Sachin. Let's append these records to the end of the more students.txt file. We'll first open up the file in append mode. As you can see by the character A, f is our file handle. We can call f.write lines and specify multiple lines that we want written out to this file. Let's check out the contents of the more students.txt file now, and you'll see that we have all of the records, but there are no new lines specified. So all of these records come together in the same line. When you open up a file in append mode, It'll create the file if it doesn't already exist, but it does not destroy the original contents of the file. If you open up a file in the write mode as specified by the W character that you pass into the open command, this will completely overwrite the existing file contents. Everything that was in the file will be destroyed. Whatever you write to the file will overwrite the existing contents. Here we call f.write and write in a completely new line. Now, if you examine the contents of the most students.txt file using the cat command, you'll find that it contains exactly one line, the completely new line. All the other records that we had written to this file earlier have been overwritten. So make sure you're very careful when you open up a file in the W mode, the write mode. Often you want some flexibility when you open up a file. You want to have the ability to read its contents and also write to the file as well. This you can do by opening up the file in the R plus mode. The R plus mode allows you to read as well as write to a file. Writing to the file using the R plus mode will overwrite the contents of the file starting from where the file handle is positioned. We read one line from this file and then using the same file handle, we write out another completely new line to this file. So if you execute this command, you'll find that completely new line. This is the line that we read from the file. After the read line command, the file handle is at the very end of the file, which is why when we now call f.write lines, it'll append to the end of the file. You'll find that another new line is written to the very end of the file. It hasn't overwritten the original file contents because of the position of the file handle. Let's try this once again. We open up the more students.txt file in the R plus mode. F is our file handle, and without reading anything from the file, we write out to the file. The file handle is at the beginning of the file at this point. We call f.writelines. Does this overwrite the file? And now if you examine the file contents, you'll see that the contents of the file have been overwritten starting from the beginning of the file. The end of the file still contains some of our old contents. Notice the last 5 characters, W space line. This is the end of the statement, another new line, which was part of the original file contents.